Out there right now, past the moon, past Mars, past the edge of our solar system, there are 100 billion galaxies, each one packed with hundreds of billions of stars. Billions and billions of planets orbit those stars. By every calculation we have, the sky above Earth should be buzzing with alien radio signals like a city at night. But when we actually point our biggest radio telescopes into deep space and just listen, we hear absolutely nothing. 70 years of searching, not a whisper, not one confirmed signal. And the more scientists try to figure out why, the more terrifying the possible answers become. So how can a universe this vast, this old, and this stuffed with potential homes for life end up feeling this empty? To understand how weird the silence actually is, you have to stare at the numbers. And the numbers are, honestly, kind of insane. Let's start small. Just our own galaxy. The Milky Way, that bright band of stars you can still see on a clear night out in the desert, contains somewhere between 100 billion and 400 billion stars. Nobody knows the exact count because even our best telescopes can't see through the galactic dust in the middle. Astronomers now estimate that at least 1 in 5 of those stars has a planet in what they call the habitable zone. That's the narrow orbital band around a star where water stays liquid, where rocks don't melt, where chemistry has a chance to get interesting. That's potentially 20 billion Earth-sized, warm, wet worlds. Just in our galaxy, just in the sweet spot for life. And the Milky Way is one galaxy out of maybe 2 trillion observable galaxies in the universe. Even if only the tiniest fraction of those worlds actually sparks life, and only a tiny fraction of those ever develop intelligence, and only a tiny fraction of those intelligences ever build anything resembling a civilization, you are still left with millions, maybe tens of millions of civilizations scattered across the cosmos. We've had radio technology for roughly 120 years. The universe has been around for nearly 14 billion. That is an enormous head start for anyone who got going before us. I mean, think about that for a second. By the cosmic clock, humanity just woke up this morning. Everyone else has had all night. In the summer of 1950, a physicist named Enrico Fermi was walking to lunch with a few colleagues at the Los Alamos National Laboratory in New Mexico. Same Los Alamos, same New Mexico desert where the atomic bomb had been built just a few years earlier. On the walk over, the group was chatting about a recent rash of UFO sightings in New York City, cracking jokes about flying saucers and little green men. They filed into the cafeteria, sat down, ordered their food, and changed topics. Then, in the middle of lunch, seemingly out of nowhere, Fermi looked up and asked a single question that has haunted physics ever since. But where is everybody? The table went quiet, because Fermi was not joking. This was the guy who had built the world's first nuclear reactor inside a squash court underneath the University of Chicago football stadium. One of the sharpest minds of the 20th century, and he was pointing at what looked like a giant screaming contradiction written across the entire night sky. Our galaxy is old, really old. If even one civilization, just one, had gotten a few million years of a head start on us, it should have had time to spread across every habitable world in the Milky Way. 1,000,000 years is nothing. Cosmically speaking, everything was already in place for the cosmos to be a noisy, crowded party. Fermi just could not figure out why the phone lines were dead. A little more than a decade later, an American astronomer named Frank Drake tried to turn Fermi's lunchtime question into actual math. In 1961, at the Green Bank Observatory in West Virginia, Drake walked up to a chalkboard and wrote out an equation with 7 variables. It takes the rate of star formation, the fraction of stars that have planets, the fraction of planets that could host life, the fraction that actually develop life, the fraction that develop intelligent life. the fraction that develop communication technology like radio, and the average lifespan of a civilization once it exists. Multiply those 7 numbers together, and you get a rough estimate of how many detectable alien civilizations should exist in the Milky Way at any given moment. Now, depending on how you plug in the values, the Drake equation spits out wildly different answers. The most conservative astronomers get about 10 active civilizations in our galaxy right now. The optimists get something closer to 10 million. Even the gloomy end of the range still predicts 10 different alien cultures pumping out radio waves, building megastructures around their stars, maybe firing probes at their nearest neighbors. We should be able to detect at least one of them. That is where the story gets uncomfortable, because we looked. What comes next is the part that still does not make sense. We did not just look, we looked hard. In 1960, Frank Drake himself launched Project Ozma, pointing a massive radio dish in West Virginia at 2 nearby sun-like stars for several hours every day. He heard nothing unusual. In the decades since, SETI, the search for extraterrestrial intelligence, has scanned millions of stars. It has analyzed trillions of radio frequencies. It has run pattern-matching algorithms on every kind of signal we know how to detect. The biggest and most sensitive instruments ever built, the Green Bank Telescope in West Virginia, the giant Arecibo dish that once stood in the jungles of Puerto Rico, the very large array stretched across the desert floor in New Mexico, all of them have been pointed at the most promising stars for decades. And in 70 years of continuous searching, we have picked up exactly one weird anomaly worth talking about. On August 15, 1977, a radio telescope in Ohio caught a 32-second burst of narrowband signal coming from the direction of the constellation Sagittarius. An astronomer named Jerry Amon circled the printout with a red pen and wrote the word "wow" in the margin. It has been called the "wow" signal ever since. It has never repeated. It has never been fully explained. And it remains the loudest, cleanest, most alien-sounding signal we have ever received. One signal, 32 seconds, in 7 decades of listening to the entire sky. That is not contact. That is at best a cosmic sneeze, which honestly is not great. For a while, scientists assumed the silence was just a technical problem. We hadn't looked hard enough. We hadn't looked long enough. We hadn't tuned to the right frequencies. That comfortable excuse is getting harder and harder to defend. And this is where the story takes a turn nobody expected. In 1996, an economist named Robin Hanson at George Mason University proposed a simple, brutal idea. He called it the Great Filter. The logic goes like this. For a dead rock to become a star-faring civilization beaming radio messages across the galaxy, it has to pass through a long series of developmental steps. Rocks have to form. Oceans have to form. Simple chemistry has to cross the line into self-replicating life. Simple cells have to turn into complex cells. Complex cells have to become multicellular animals. Animals have to grow brains. Brains have to invent language. Language has to become writing. Writing has to become science. Science has to become technology. And technology has to survive long enough to actually reach out into the cosmos. Every one of those steps is a filter. Something has to make it through. Somewhere along that chain, Hanson argued, there has to be at least one step so impossibly hard that almost nothing makes it through. That step is the Great Filter. That is the part that keeps astrobiologists up at night. The Great Filter is either behind us or it is ahead of us. If it is behind us, it means we already did the impossible thing. We are cosmically rare. We are the one lucky species in the haunted mansion. If it is ahead of us, It means we are about to slam face first into whatever wall every civilization before us hit. And based on the silence so far, nobody else has ever climbed over it. The clock was already ticking. Humanity just couldn't hear it yet. Let's start with the filters that might already be behind us in the rearview mirror. Number 1 on the list is abiogenesis. That is the jump from non-living chemistry to an actual living, copying, breathing cell. On Earth, this happened fast, at least by planetary standards. Our planet formed about 4.5 billion years ago. Within maybe a few 100 million years, somewhere in our early oceans, probably around hydrothermal vents on the seafloor, some lucky chemistry packaged itself into a membrane, started copying itself, and became life. But fast does not mean easy. We do not know whether abiogenesis is common or whether it was a once-in-a-universe lottery ticket that only got punched on this one rock. Nobody has ever recreated it in a lab, not even close. If life is easy to start, the Great Filter is probably ahead of us. If life is nearly impossible to start, the Great Filter might already be in the history books. Number 2 is the eukaryotic cell. For the first 2 billion years of life on Earth, the only living things were simple bacteria. Tiny, lonely, floating around in the ocean, doing basically nothing interesting. Then, about 2 billion years ago, something genuinely weird happened. One kind of bacteria got absorbed by another kind of bacteria, and instead of being digested, it just moved in as a permanent roommate. That merger created the first complex cell. Every plant, every animal, every fungus on Earth is descended from that single event. It happened once. It never happened again. Biologists call it the single most improbable event in the entire history of life on this planet. And no, I'm not making that up. Number 3 is intelligence itself. Life on Earth existed for nearly 4 billion years before anything developed the kind of problem-solving, tool-using, language-speaking intelligence that humans have. Dinosaurs roamed the planet for 160 million years and never got anywhere close to inventing the wheel, let alone a radio telescope. Sharks have existed essentially unchanged for 400 million years, absolutely thriving in the ocean, completely uninterested in algebra. Intelligence might not be the inevitable endpoint of evolution. It might be a weird, costly, improbable side experiment that got tried exactly once on exactly one planet, which is a humbling thing to sit with. If you are finding this rabbit hole as fascinating as I do, hit subscribe. We break down the biggest mysteries in space and science every week, and there are a lot of them worth freaking out about. While Earth was quietly lucking its way through billions of years of biological near misses, something else was brewing in the background. The cosmic clock was still running, and it has a nasty habit of resetting. This is where things get properly unsettling. Because if the Great Filter is not behind us, it is still coming. And once you start listing candidates, they start to look uncomfortably plausible. Candidate number 1 is self-annihilation through weapons of mass destruction. Humans invented the atomic bomb in July 1945. Within 20 years of that first test at the Trinity site in the New Mexico desert, we had accumulated enough nuclear warheads to wipe out all large life on Earth several times over. We came within minutes of full nuclear exchange during the Cuban Missile Crisis in October 1962. We came close again on September 26, 1983, when a Soviet officer named Stanislav Petrov watched a Soviet early warning computer report 5 American nuclear missiles inbound toward Moscow. Standard procedure was to immediately report the launch up the chain, which would have triggered a full counterstrike within minutes. Petrov, against protocol, decided the computer had to be wrong. He was right. If he had been wrong, the 20th century would have ended that evening. Every civilization that invents nuclear technology has to decide every single day, forever, not to use it on itself. That is a brutal bet to have to keep winning. Candidate number 2 is artificial intelligence. We are less than a century into the computing era, and we are already building systems we do not fully understand. Some thinkers, including the Oxford philosopher Nick Bostrom and the late Stephen Hawking, have argued that a sufficiently advanced AI system with misaligned goals could be a civilization-ending event. Not because it would be evil, but because it would be optimizing for something that does not include our survival. We do not know yet whether this is a real risk or good science fiction, but any advanced civilization in the galaxy has to pass through this exact technological window at some point. If the window almost always collapses on whoever is standing inside it, well, that would explain the silence nicely. Candidate number 3 is ecological self-sabotage. Climate instability, biodiversity collapse, dead oceans, poisoned air, planets are fragile. Any species that gets smart enough to rewrite the atmosphere without getting wise enough to stop itself might simply exhaust its biosphere before it ever reaches the stars. Earth is the only living biosphere we have ever studied. We might be watching a prototype fail in real time. And somehow it gets worse. Because the same intelligence that carried us off the African savanna and onto the surface of the moon is the exact thing that might end up getting us killed. But even assuming we manage to thread every one of those needles and survive the filters ahead, there is one more possibility that astronomers have to take seriously. And it is probably the scariest one on the whole list. The dark forest hypothesis was popularized by the Chinese science fiction author Liu Cixin in his novel The Dark Forest. But the underlying idea comes straight out of game theory. The premise goes like this. The universe is a dark forest at night. Every civilization in that forest is a hunter, moving quietly between the trees, listening hard. If you hear another hunter out there, you have two options. Either stay absolutely silent and pray they do not find you, or destroy them before they can destroy you. There is no third option. Because you can never tell whether the other hunter is peaceful, you cannot afford the risk of being wrong. A peaceful civilization that announces itself to a paranoid one gets wiped off the map. A paranoid civilization that stays silent survives. Over cosmic timescales, the only survivors are the silent ones. So the optimal strategy, the one any truly advanced species would eventually converge on, is to shut up, never send out radio waves, never build a Dyson sphere that radiates detectable infrared. Never do anything that looks like a signal. If the dark forest hypothesis is correct, the sky is not empty at all. It is full. It is full of terrified civilizations, huddled quietly around their home stars, hoping nobody ever notices them. And humanity, by blasting I Love Lucy reruns in every direction for 70 years, has been screaming in a haunted forest like drunk tourists who wandered off the trail. Somewhere in the darkness, something might already have heard us. The real question is what happens when it decides to answer. There are softer versions of the answer too, if you want to sleep tonight. The rare Earth hypothesis, proposed by paleontologist Peter Ward and astrobiologist Donald Brownlee in the year 2000, argues that Earth is a statistical fluke, a stable yellow dwarf star, a large moon that tilts our axis at just the right angle to give us seasons, a gas giant, Jupiter, acting as a gravitational shield that swallows most of the incoming asteroids before they can hit us, plate tectonics, a strong magnetic field, a breathable oxygen atmosphere, all of it stacked in our favor. Rare Earth says we are alone simply because we are freakishly lucky, not because anything sinister is happening. Then there is the zoo hypothesis. Maybe advanced civilizations are out there, plenty of them, but they have all agreed not to contact us. We are a nature preserve, a cosmic Galapagos. They are watching us from the outside, waiting for us to mature, and they do not want to contaminate the experiment. And then there is simulation theory, which says maybe there is nothing out there because there is nothing out there to find. We are running inside somebody's computer, and the developers never bothered to code the aliens in, which is either strangely comforting or the bleakest thing you will hear all week. I genuinely cannot decide. But whichever of these hypotheses turns out to be closer to the truth, the implications stretch way beyond astronomy, because at some point you have to sit with what the cosmic silence actually means for us. This is where it all lands. Regardless of which filter we are talking about, the silence gives us two possible answers. And every scientist who sits with these two options long enough finds both of them deeply unsettling in different ways. Answer one is that we are early. The universe is still young. The chemistry has only recently stabilized enough for life, and we are among the very first intelligent civilizations to crawl out of the primordial soup and look up at the sky. That sounds like a win. It is not entirely. Because it also means we do not get a guidebook. No older species has left us notes on how to survive the nuclear era, the AI era, the climate era. We are the first to try. If we screw this up, there is nobody around to learn from our mistakes. Answer 2 is that we are alone because the great filter is lethal, universal, and still waiting for us. Every civilization before us hit it and vanished. Their radio signals stopped. Their megastructures never got built. Their home worlds went dark, one after another, for billions of years. And the silence we are hearing is not the silence of an empty universe. It is the silence of a graveyard. I mean, think about that for a second. Either we are the first, or we are the next. The Fermi Paradox has been around for 75 years now, and we are no closer to cracking it than Enrico Fermi was over that lunch in Los Alamos in 1950. Every new exoplanet we discover, every new telescope we launch, every new decade of silence from the sky, the question just gets sharper. The real question is not whether anybody else is out there. It is whether everyone who is already out there failed the test we are about to take, and whether we are the ones who finally pass it. If this kind of cosmic existential dread is your thing, go check out the video I made on the Kardashev scale and what a truly advanced civilization would even look like. Until next time, keep looking up at the stars, just maybe don't wave.